Composition of shapes. After the lithotripsy procedure, Gianna passed the particles of the original kidney stone at home. Per her doctor's request, she has brought the kidney stone fragments into the healthcare clinic to send away for testing. Begin the testing process by using the information below to determine the area of one of the irregular shaped kidney stones. And so you can see below that this is an irregular shape that has no formula. So to find the area of irregular shapes, we will separate the irregular shape into shapes with known formulas. And then 2, we will add the area of the shapes together. So let's go ahead and go back to our problem. And we can see that there are 3 shapes. We can break this down into a rectangle that is a square and 2 triangles. So let's begin by finding the area of the square first. So we remember the area of a rectangle or square is length times width. So we can see that the length and the width are the same size. So we would see that 1 milliliter times 1 milliliter is equal to our area of our square. So this is just equal to 1 milliliters squared. So we'll label that. Then the triangle. Let's look at this top one first. So we remember that our triangle area formula is area equals 1/2 base times the height. So 1/2. Now we know our base is right here, which is shown to be 1 milliliter. And then our height, which is going to be 2 milliliters. So we go ahead and calculate this out. So numerators together, 1 times 1 times 2 is 2, divided by then 2, which is equal to 1 milliliters squared. So now let's look at this last triangle. So the area is the same, 1/2 base times height, which is equal to 1/2. Now our base is going to be 1 still, but our height is actually 3. So 1 times 3 is equal to 3 divided by 2, which is then equal to 1.5 milliliters squared. And then our final step is to add these 3 numbers together. So 1 plus 1 plus 1.5 is equal to 3.5 milliliters squared. So this is the area of our irregular shape. So let's look at another example. After the lithotripsy procedure, Hector passed the particles of the original kidney stone at home. Per his doctor's request, he has brought the kidney stone fragments to the healthcare lab's drop-off location for testing. Begin the testing process by using the information below to determine the area of the irregular shaped kidney stone. And so in this example, you can see that we have 3 different kinds of shapes. We have a half circle, we have a rectangle, and we have a triangle. So we will need to find the areas of these 3 different shapes, and then we'll add them all together. So let's start with the half circle. So technically the area of a circle is pi r squared. Now we can see that we know the diameter because this is the length of the whole circle. So the radius is to divide the diameter by 2 to get the radius. So 4 divided by 2, which is equal to 2. So r equals 2. So we're going to solve for the regular circle first. So pi, which is 3.14, times 2 squared. So to get our calculator out, 2 times 2 equals 4, times 3.14, which is equal to 12.56. Now, we know though that we have only half a circle, and this is for a full circle. So we will need to divide by 2 in order to find the area of the half circle. So this gets us to 6.28 milliliters squared. So now let's find the area of a rectangle. Area equals length times width. So we know our length, which is right here, is equal to 10 milliliters. And now our width is equal to 4. So 10 times 4 is equal to 40 milliliters squared. Then, for our triangle, our last shape, we know area equals 1/2 base times the height. So we have 1/2. Now our base, we can show as 5. And we have a height, which is shown as 4. So we have 1 times 5 times 4, which is equal to 20 over 2. And 20 divided by 2 is equal to 10 milliliters squared. So this is the area of the triangle. So now our final step is we're going to need to add these together. So we have 6.28 plus 40 plus 10, which is equal to 56.28 milliliters squared. And this is our final answer.